Hello, this video is for chapter 2.1 for statistics. We're going to try to summarize. The chapter 2 is called Descriptive Statistic. We are going to summarize quantitative data. So if you have a set of data that is purely numbers, it's either a measurement or count. So we want to see how we can summarize it. When we say we summarize it, what are we paying attention to? Of course, we want to have five area that we want to look at. This five. Center, what is the middle of the data? Variation, how does data vary? How do they spread out? Distribution, what is the shape of the distribution? That means where is the center? Like, is it in the high end? Is it in the low end? What's the shape? Or is it like right in the middle? Do they spread out? So variation talks about how much they spread out. Do they spread out a lot or highly concentrated around a small area? Distribution is about how, in what shape the data are located. Primarily where the center is. Are there two center like that? Outliers, is there exceptionally high or exceptionally low data? Trend is if the data are collected over time, is there an upward trend, downward trend, or cyclic periodic trend? So whatever that we summarize, we would look at, see if the tools that we use will give us this five area. So primarily we can memorize it by remembering CVDOT. Okay, CVDOT. It's a little like COVID. So the first things we can summarize quantitative data is by graph. So there's two like minor one that we use called dot plot and Stemplot. These are less important because they have very high restriction in that it's not useful if the data is have a big range or you have large data. But it is useful if you have small number of data, like less than 20 or 20 something data. It is quite useful. These two plot can show you where the center is, how data varies, and also the distribution, and possibly if there's outliers. Okay, so the main one that we can use is histogram, but we'll develop the concept by looking at what dot plot and stem plots are. And then lastly, we also would use box plot, and in particular, not the regular box plot, but the modified box plot. Maybe I should actually change the notes to say modified box plot. A modified box plot is used to determine if there's outliers. So particularly for outlier, histogram is particularly for center, variation, and distribution. Okay. So what is a dot plot? Dot plots are used to graph small data set in a very small range. If your data doesn't the value itself doesn't change a lot, like within a fixed range, and it's all discrete, so it is possible to stack the repeat data together so that you can actually kind of make a graph. Each data represent dots. Okay, so this is a dot plot that shows the time in minutes for a runner to run 5K. Okay, so these are the data that they collect. How many runners finish in 32 minutes? So these are the minutes. You see the horizontal axis. There's only one axis. Horizontal axis, 26 means that, someone finished in 26 minutes. 32 means finished in 32. And there's two dots here. That means there's two runners, right? So each dot is a data. Now, so if there's three dots, it doesn't mean there is a data of 3. This just means there's 3 data of 30. So you can think of, I can rewrite the data out. So if I want to, I can say, okay, I have a data of 25 and then 28, 28 like that. Okay, so that is the real data. These are summarized. But you need to know how to read a dot plot. Okay, what's the number of runners? How many runners are there? We can just count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 here. And then 1, 2, 3, 4, 5, 6, 7. So totally 17 runners. So 17 dots, 17 runners. More runners finish less than 32. Okay, so 32 is like a a mark that they want to like a demarcation. Less than 32 minutes. How many are less than 32? So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 less than, right? How many are more than 32, excluding 32? More than means not including. 1, 2, 3, 4, 5, 6, 7. Only 7. So more runner finish less than, because there's 8 of them less than 32 minutes. So that means if you look at your data, there are 8 data value that are less than 32. So example 2 is actually practice doing a dot plot. So these, remember, these are the real data. This is number of hours of sleep for a sample of patients. Wow, someone sleep 3 hours only. So you can see when you do a dot plot, you just write the number. So if it shows up and you don't skip anything, 3, 4, 5, even if it doesn't shows up, you still have to do it. 6, 7, 8, 9. Okay. Then you say, so basically you look at this lowest number, the highest number, and then you get all the number in between. And you just go through them. 3, you cross it out. 4, you cross it out. 5, you cross it out because you graph it. 7, 8, cross it out, and then 9, you cross it out. 5, oh, there's another one, so you stack it up. 6, there's none. 7, oh, there's another, there's actually 4 more, so you would have stack up 1, 2, 3, 4, 5. So that is a dot plot. So it has to be like small variation of data and in a small range. Describe the shape of the distribution. Um, so when we look at shapes of the distribution, is it symmetrical? So right now I haven't talked about the shape of the distribution. It's not symmetrical, but they're more, the high number is on the right side. So like the middle numbers are on the right side. So most of the data is on the high side. So we call it skew. So we can say skew, not symmetrical. So for the time being. Later on, when in 2.2, I will talk about the actual name of all the distribution, the shape. Stemplot. Stemplot is another way to graph relatively small quantitative data, but instead of having one number at the x-axis, they group them in tens or 5. So basically, all numbers are grouped into a stem or are written into a stem and a leaf. So, so this is a typical stem plot. So this showing pulse rate. So pulse rate, like the heartbeat per minute of a sample of adults. So what do they mean? So if I see 6, so this is a legend. 6/3 means 63 BPM. So the way you read it is 63 and 65. So if you are to rewrite the data out, you say 65, 63, 65, and then 78, 79. So 7, this is called a stem. The last digit is called the leaf. So you write the leaf once only. So each digit here represent one data, right? And then you go on. So what does the row 7, 8, 9 means? It means a BPM of what? 78 and 79. Okay. How many adults are in the sample? So each one of the leaf represent one data. So 1, 2, 3, 4, 5, 6, 6, and then 5 more. So it's 11 adults, right? You should basically count the number of leaves. What is the lowest pulse rate? The lowest pulse rate would be 63. What's the highest one? The highest would be 99. Okay. Highest is 99, but they didn't ask it. Okay. So that's how you read it now. Practice doing it. Um, hmm. So we say we need to write the stem and we need to write the leaf, right? So what is the lowest number? The lowest number is 19. The highest number is 30, 30, 30, 38. So we would have 1, 2, 3, right? So then we write all the stem. The leaves are the last digit. Okay. So I have 19, another 19, 21, 25, 25, 26, 29, okay, 31, 32, 34, 36, 37, 38, 38. Oh, and then I have a 43, so that is it. Is this symmetrical or is it scale? I think it's kind of symmetrical, right? 2.2 is histogram. So I'm going to record this in another video. But you can see these Stemplot. Now, when you look at the Stemplot, the distribution is look at it this way, right? So this is the highest class. Most data around here. So that's called the center. It doesn't vary that much, and also the shape of the distribution is symmetrical, is not scale. Okay, so I will talk about 2.2 in the next video.